Hello, I'm Adam Pease, and today I'm going to talk about a programmer's text editor for a logical theory, which I've called the SUMOjEdit editor. Everything that I've done here is open source, all reachable from ontologyportal.org or from GitHub, and I also have a number of videos on my YouTube channel that show the editor in action as well as various other sorts of discussions. So the problem statement is that I write a lot of statements in logic in conjunction with the SUMO theory. It uses a fairly expressive logic. It's a higher order logic, although most of the actual theorem proving work that I do is in first order. But basically, there isn't a simple visual metaphor. We can't just be editing graphs as we do in a taxonomy or a description logic or a frame system. All the editing's done in a text editor, like most modern programming and as well as most interactive theorem proving that folks are doing here. There's a big library of theories in SUMO. I'll talk about that in a moment. And so there's also a challenge with remembering all of the terms. The relations all have a defined type signature, and so sometimes remembering all of that can be challenging because there are thousands of different relations. I also had a need to try to make it a little bit easier for people to come up to speed on editing SUMO and making new content. So I wanted to make it easier for newcomers to write good code. And primarily, I'm using automated theorem proving rather than interactive theorem proving. But there is a sort of mode where you're trying to get a particular inference to get you an answer, and it winds up, I think, being more like interactive theorem proving. And so I wanted to apply some of the metaphors for the editing process that folks in interactive theorem proving use, but in this sort of first order framework where I'm using primarily completely automatic provers. So this past fall, I had the opportunity, or the burden, one might say, to do a very quick project. I had about 10 days to gather a group of people to work on the project. The project only lasted a couple of months, and so I had to get people with no prior logic experience. In my case, there were just 3 folks that were pretty much right out of college with a bachelor's degree in computer science and really no prior experience with logic or logical theories. And I had to get them up to speed really fast. And so I did a little bit of tracking as to the sorts of errors that they made during their initial ramp-up period of working on SUMO and adding to it. And here's some of the results. So obviously a lot of errors were just errors of conception, right? Where the axioms that they wrote just didn't really conform to the requirements or conform to the reality of the domain that we were working on. I call those semantic errors. So those are certainly the bulk of the errors. And there's not much we can do there to make sure that a machine can catch those kinds of errors. But the rest are things that are pretty straightforward and easily automatable. So using a class where an instance is required or vice versa. Errors in type, so violation of the relation signatures that I've mentioned, using a term name that maybe has a typo in it, or especially a simple error of capitalization, so getting people to realize that capitalization is significant, always for some reason is kind of an issue. Unused variables, so just a simple typo in a variable name can mean that you've got a variable that doesn't get referenced later in a rule, for example. Syntax errors, things like balancing parentheses. People can sometimes be sloppy about that if they're not used to languages like this one that are Lispy and require balanced parentheses. And then things about argument order and number are also common errors. So the theory I worked with is called SUMO. Hopefully some of you have heard of it. I started this work in the year 2000, so it's been now 2 decades that I've had the chance to work on this comprehensive upper ontology that has really turned into not just an upper ontology, but a comprehensive ontology, an ontology that includes information about a lot of different domains. So there are dozens of those now, and the combined system has about 20,000 terms, 80,000 statements that have been written by hand, but also some big fact bases of millions and millions of simple factual statements that have been pulled in from Wikipedia or other database sources. And we've also gone through and mapped it to a big lexicon, the WordNet English lexicon, which now is expanded to include Global WordNet, as it's called, that has some 24 different languages. And so that's been really useful for studies in lexical semantics and NLP applications. Along with developing SUMO, also have developed a knowledge engineering environment for the system, really right from the start. So the idea was to be able to take these source files that are written in a text editor and read them into a system where it can do some error checking, or essentially you can think of it as even compilation. Very much similar metaphor to what you would do in a modern integrated programming development environment. So if you were writing in Python or Java, you might use IntelliJ or Eclipse, and you write your source files, and the system is all the time parsing them and trying to give you, menus and summary features and analyses that help you do a better job as a programmer. So I wanted to have this sort of same support in this completely declarative language of SUMOkif, that's the logical language, with the SUMO library, in the same way that one has Python with the Python libraries or the Java language with all the Java libraries. It's really pretty much the same metaphor. And as well the same metaphor with having an IDE where the bulk of your work is done in a text editor, but layered on top of that text editor are lots of tools to make your job easier. One of the things we do is, because there's no native implementation of the particular syntax and logic I've chosen, is that I've developed a number of translators over the years, especially in conjunction with Jeff Sutcliffe and his team of students and colleagues. So early on we developed a translator to TPTP. A bit after that, I worked with Chris Bensmuller, and he developed a translator to the THF language, typed higher order form, and then more recently, with the advent of the typed first order form, I developed a translator to the TF0 language. I have native interfaces to E and Vampire, as well as Jeff's system on TPTP. And all of this was reusable for SUMOjEdit. It wouldn't have been possible to write this editor with all the support that it has without having implemented basically all of the back-end analyses first in Sigma. So I'm really just using Sigma as a client with the editor to call it. So the editor features are pretty straightforward, things like color coding. So being able to highlight logical operators, the fundamental relations, documentation strings, comments, all this just visually makes editing a lot more easy and reliable, as it does with almost any other programming language. I've got an analysis tool that will flag the kind of errors and warnings that I highlighted in the statistics that I showed about people learning SUMO. It includes a standard formatting, again, like most programming language tools. You can also open the browser to get the sort of more traditional view of SUMO with hyperlinked, nicely formatted collections of all of the logical statements. You can go to a definition. So this is an interesting thing where definitions, these are not necessary and sufficient definitions for most terms. So they're not definitions in a strict mathematical sense. If you want to define something like the concept of walking in SUMO, you have necessary but not sufficient conditions. And also the statements about that symbol can be distributed in principle over several files, although you'd prefer not to do that. Things do evolve a bit organically, just like any large programming project. So there's a little bit of complexity in trying to determine where is the definition of the term. So we look at fundamental relationships like where you define walking as a subclass of ambulation. That with the subclass relationship is an indication that's probably where the most important definition is in a file for a particular term. And then lastly, theorem proving, which I mentioned, I'll show a little bit more information on. So here's a screenshot just showing what the system would look like when you're opening it on your computer. It shows the command line just with some status messages. The center window there is the actual SUMOjEdit window. So this is all built on top of an existing pretty powerful and well-supported editing system called JEdit. I chose it really just because I wanted to stay in Java, because that's what all of the Sigma system is written in. And this was one of the really the only full-featured editing system that had plugins, and had plugins that were well enough described that it was really easy for me to get started. This should be possible in principle with IntelliJ or Eclipse, but I really had a lot of trouble figuring out their documentation and getting it working, whereas JEdit was a lot more straightforward. Another thing that would be interesting would be to try layering this on top of Emacs. I believe that Isabelle, for example, has a nice Emacs interface for their system, and that would make eminent sense and should in principle be quite easy to do. I'm just not an Emacs whiz, so I chose JEdit. Here, this view shows the error list that you can get. So if you ask for an analysis of the file, it'll pop up a separate window with all the errors and their line numbers, so it's nicely clickable, and you just click on the error and go right to the line. And it shows not only errors but warnings. Here it's showing a list of warnings that in reality are not problems, but they are often indicative of problems. So even when the error checking system can't determine strictly whether you've got a syntax error or a type violation, there's still some other hints it can give you that will improve the quality of your code. And let's show just one more screen here. This is a view of just a proof. So there's a pretty simple interface that you can highlight any statement in your editor and then right-click and have it have that statement sent to a theorem prover as a conjecture. So in order to do that, we do a round trip through the TPTP translator. So from the SUOKIF, it gets converted to TPTP. It then gets sent to either E or Vampire, and that's your choice. And that's selectable. And then when you get the proof back, even though E and Vampire are sending back the proof in TSTP3, I believe it is, we do a conversion back to Sumo as best we can. There are a lot of transformations. We've got some prior papers. We talk about that in detail. If those folks are interested and want to contact me, I can give you that link. But it actually, those papers were presented at CADE or IJCAR in prior years. Okay, so that's really it, and be interested in having your feedback, and please take a look at all these resources online and let me know what you think. Thanks very much.